and see your YouTube calculator. Okay, let's continue the enthalpy change of reaction or the Hess law, constant heat of summation under study general chemistry lecture. So I have here examples. I prepare some examples because there's a lot of chemical reactions. I cannot memorize everything, really. Okay, this is all about, what's this? Okay, this one. What's this? 2 moles of water. Is number 4, right? Okay. Klaro din ang mga palangga. O, ganon. So, 2 moles. 2, what's that? 2 H2O. Okay. Will yield 2 moles of hydrogen gas plus oxygen gas. Okay, delta H for this reaction is 572 kilojoules. Okay, so this is non-spontaneous and endothermic reaction. Okay, and then we have another equation number 2. Oxygen gas will yield, what's this? 2O. So this is not common, that 2O, guys, for oxygen. Actually, we have different allotropes of oxygen. Allotrope meaning many physical forms, but the same element. Okay, for example, carbon, it exists as graphite, diamond, like that, or shall we say bitumens, the black color used in the asphalting, something like that. Okay, then when we burn of something, for example, we burn sugar, and then body there's a black color, so there's a process of carbon. So there's another form also, like a solid residue, black color. So these are allotropes. Okay, various physical forms but the same element. So in here also we have diatomic oxygen. Okay, diatomic oxygen, di meaning 2 atoms of oxygen. We have also 3, which is the ozone layer of the sun. So we have 3 atoms of oxygen. But in this case, you have 2 atoms of oxygen. That's diatomic, that's general, no specific name. Okay, but the ozone layer of the sun is specific. Okay, that's ozone. You get the point? Okay, so it will become thinner and thinner and thinner due to greenhouse gases exposures, something like that. I told you that it's a physical form, meaning allotropes of oxygen. Get the point? But the normal oxygen is O2, oxygen gas. We have O3, and you have also the atomic oxygen, this one. Okay? Get the point? Actually, it's just like the chlorine gas. Okay, and it will yield to twice chloride, something like that. Okay, but in here, it's not the halide family. Okay, it's not also the oxide, but it's really oxygen. Why? Because there's no charge. Okay, see, 2 oxygen, no charge negative, no charge positive. But in here, 2 chloride negative, halide group. Okay, get the point? Even though it ends in IDE, but it's not the same family, right? Or group in the periodic table, the oxide. Okay. Okay. Oxide meaning negative 2, right? Okay. So going back to this, so this is our equation number 2. Okay, can you equation number 2? Positive 49. Again, endothermic. Okay, reaction and non-spontaneous. Okay. 495. Okay, 495 kg. Hello. Okay. Okay. Now we have the overall chemical reaction here. So it's given H2 plus O. Oh my gosh, monoatomic oxygen. Nakakaloka. H2 plus O is equals to H2O. Right? Actually, this is not really in reality, because oxygen will exist as oxygen gas when it react to hydrogen gas. But for the purpose only of sample problems for this topic, then we need to introduce in this way. See, oxygen, there's no subscript, there's no atom. So this is monoatomic oxygen. And this is diatomic oxygen. Okay, something like that. Okay. Now this is equation 1. Chemical equation 1, chemical equation 2, and this is our overall reaction RxN. So we are mandated, we are required to compute for the delta HRxN, question mark. We need to compute for the enthalpy change of the reaction or the heat of the overall chemical reaction. Okay? Ganon. So we cannot use the delta H Rxn or Q heat over N. Why? Because this is intended for individual equation 1, equation 2. This is overall chemical reaction. You get the point? So we cannot use this one. Standard formula for heat of reaction. Okay? So if you want to solve individually, then you can also. Even though without looking at the delta HRxN, you can solve for how is the heat energy content of H2O, H2, O2 by having this only enthalpy change of reaction, 572. Okay, but we are not concerned for that. Okay? Get the point? We are in the Hess law constant heat of summation. Okay, now we have this overall chemical reaction. So we need to have this chemical reaction final. How to do that? So the first step is to add the two. Option 1. Okay, add the two. So 2H2O, okay, plus oxygen gas is equal to 2H2 plus 1 plus 2, so 3 moles of oxygen gas. So this is the final equation. And then since oxygen gas in the left and oxygen gas on the right, so transpose, it will become 2H2O. So 1 minus 3, it will be transposed there, negative 3. This one, 3, negative 3. So 3 minus 1 is 2, right? Okay? Because we don't have negative number of moles in chemical reaction, it's always positive. So in math, it will become negative 3. So transpose, so positive 1 mole of oxygen gas minus 3 moles of oxygen, it will become negative 2. Okay? But we don't have negative in chemical reaction, but it's also still the same as 2 moles of oxygen gas. You get the point? And 2H2. So you can never see a chemical reaction that have negative in the reactant and in the product. The delta H can have, okay? But for the chemical reaction, okay, no, nothing, ha? Puros gina siya plus, guys. Okay? Like that. Now take a look at the product we have here. So 2H2O like that. So it's not the same, right? So this option number 1 is wrong. Okay. How about option number 2? How about reversing equation number 1? Okay. And then add to equation number 2. Okay. So O2, okay. So reversing now. So O2 plus 2H2, okay. Then 2H2O, okay. Then the 2 will not be reversed. O2, okay, is equals to 2O. And then add on. Okay, so if you reverse the first equation, then you will say negative this one. Okay, the delta H of the first equation will be reversed, right? Okay. O2 plus O2, 2 moles of O2, right? 2H2 is equal to 2H2O plus 2O. What can you say of the result? 2O2, 2H2, 2H2O, 2O. It's just the same with this. Try to compare. This one. So we have H2. Okay, but there's no oxygen gas. Okay, there's no oxygen gas here. Okay, so this is wrong also. Okay, ganon. So remove this one. We will not reverse it. And I will reverse the second one. Option number 3. Reverse the second one and add to the first one without reversing. So it's gonna be 2H2O 2H2 plus O2. This is option number 3. And then 2O, O2. So add 2H2O, 2O, 2H2, O2, plus another O2. This is 2O2. 2O2. So take a look. So 2H2 plus 2O2, H2, 2O2. Is that the same? H2 plus O. No, H2. It's wrong also. Okay. How about reversing the 2? Option number 4, and add. Number 4. So we have 2H2 plus O2 equals to 2H2O like this. Then 2O. This is just happening, guys, because I don't memorize. I don't memorize how it is being done. That's why it takes me a longer to have option 1, option 2, option 3, option 4. In order for us to understand really what's going on. Because if we try to go direct, meaning we memorize, okay, how it is being done. I don't want to memorize how it is being done. We need to, to do the proper way of, having options until we get the correct one. Anyway, if you can face the examination in the future, go to the direct and straightforward in doing that. The purpose only is to understand why. Because I go to the rule number 1, rule number 2, rule number 3, rule number 4. So really the basic foundations how to do it. Okay, not to go directly and then the students cannot understand. Sometimes if we go directly, they may wonder why, why like this? Okay, so we need to have the substance of the discussion, to extract really what is the correct way how to do it. Okay, so that in the future, if it will be rumbled, modified, variant, then you can answer even though you will not be dependent on the way how it is being done always. This is always an issue. In our classroom instructions, they always do it in that way, in the sample problems, in the examples. But when they give the exam, they will add something that they did not discuss, but relating to it. That's the technique of the instructors. Okay, then majority of the students cannot get it, except to those have high mental ability to have a quick IQ. So, but there are only few out of them. So we cannot expect all of them will get. So we project the majority in our discussion. So this is not a classroom instruction or face-to-face instruction, but this is only an interactive online platform way of discussion. But I'm just telling the way it should be, something like that. Okay, you get the point. Mga palangga. You get the point? Okay, something like that. So option number 4. 2H2O, then reverse that. It's gonna be, so 2O is equals to O2. Add them all. So 2H2 plus 3O2 is equals to 2H2O plus O2. Kabo. Then, what's that? H2, the same properties. This one and this one. 2H2, okay. Actually, this number 4, option number 4 is just already going to be correct. But there are number of moles of hydrogen 2, and there is also number of moles of 2 hydrogens. So what you will do for this, and there's oxygen of 3, ganon. So if you multiply this whole thing with 2, it's impossible for this to become 3. So this is already correct. We need to reverse the 2. And we need to go to the option number 5, the last, manipulation of multiplying the number of moles. Most of the times, guys, as you can witness, it's always the number of moles multiplication with the quantities will matters at the last. So this will be our clue already that we need to go directly sometimes in doing that. Since we tried already 3 examples that needs to have like that situation. Okay, so it's gonna be the priority to multiply that to something so that we can eliminate and cancel out the same quantities. Okay, it helps us to conclude that it's gonna be like that always. We need to multiply with a certain number of moles so that it will be cancelled out, the commonalities or the common with the left and the right. Okay, ganon. So it's already correct, so you have to reverse the 2. Okay, then manipulation of the number moles to be multiplied. Okay, so it is, oh my goodness, okay, so we have O2, 2, actually it's O2 here, okay, Actually, guys, wait for a while. Okay. So if you try to reverse, it is okay. Okay. Reverse na siya. So reverse ang duha, sakto siya. Then, para makasalin mo ang O2, what we will try to do? So you need to add the O2, right? You need to add the O2. So you need to add the O2 and add this one like that. Okay, but reverse. Okay? Dito na siya, reverse na siya. 3 O2 minus 1 O2 is 2 pa man din siya. So we need to equalize that one. Okay, ganon. So we need to multiply this by 2. Okay, let's try it. Okay? Not 2, I think, start gyapon ka sa minimum. As what I discussed to you earlier. 1, 2, 3, 4, 5, 6. But if you multiply this by 1, it will never cancel because it will produce also O2, O2, and then you reverse that both here in option number 4. So you cannot cancel that one. Okay, if you reverse that one, all O2 will be going to the there. You get the point? O, diba? So we need to multiply this with, I think, 1/2. Because 3, it will complicate. It will become 6. It got 6O, and then it will not balance with the equation. Go to the minimum, then 1/2. Okay, try to multiply this by 1/2. 1/2, this equation 2, and then this delta H 495 will become negative because you reverse that one, so negative, and then multiply by 1/2, then divided by 2. This enthalpy of reaction of equation number 2. So how much? Every time you manipulate, okay, you should also manipulate the delta H. So 495. So because the answer will be this here. 495 divided by 2 is equals to 247.5 negative exothermic reaction. 247.5 kilojoules. Oh, ganon. So again, option number 5 with the manipulation of multiplying with the moles or coefficient to cancels out the common of each sides. Okay, I have to multiply the 1/2. So okay, so I need to do that again. So 1/2 times 2 oxygen only. Okay, question 2. 2 reverse this one O2, so that is 1/2 times O2 plus. Okay, plus. Here, what you will multiply this here so that it will cancel our O2. Okay, so we need to multiply this also by 1/2, right? Or else it will not be cancelled because there is already a fraction in your second equation. So manage also to put fraction in your second equation. Okay, so that it will be cancelled later on or something like that. So we have 2H2 times 1/2 is equals to H2 na lang siya. H2 plus oxygen gas times 1/2 mole of oxygen gas. Okay, and then 1 mole of H2O. Then add this to, if it will result to the overall chemical reaction. Okay, mga palangga. So reactants H2 plus 1/2 mole of oxygen gas. Actually, this is also 0.5 mole of oxygen gas, but we avoid points in our chemical reaction. Okay, like that is equal to, so later on, we need to erase this fraction. Okay, but wait, this is on process. Like that. So H2 plus 1/2 oxygen gas is equals to 1/2 oxygen gas plus water. Take note what is cancelable down here, or comma to the left and right. It is the, wait, okay, 1/2 oxygen gas. Okay, cancel the 1/2 oxygen gas, cancel the 1/2 oxygen gas. So it will become H2 plus O is equals to H2O. Okay, it's just the same there in the upper common reaction. Oh, perfect, it's the same. H2 plus O, H2O. Ganon, diba? It's gonna be the proper way of discussion. It should not be prepared ahead of time, right? So it should be on the spot. So H2 plus O is equal to perfect, right? Since we manipulate this by multiplying by 1/2, the reverse also, so negative by 7, 2 divided by 2. also in the first equation. It takes a long process pala siya, guys. Kaya pala. Okay? That's why they will never put this in the examination, the board examination. It's divided by 2. There's a lot of, you know. So 286, negative 286 kilojoules. Okay? Like this and this one. So add now the overall heat of reaction or the enthalpy change of reaction. Erase na taani. So you will say mga palangga, so Sotero, how about you go directly to the reversing both and then multiplying with moles? You can have also. That's only my discussion to make it proper, right? It depends on you if you want to be direct. Okay? Like that. Okay? Like that. So it's gonna be delta H of reaction. So delta H of reaction or heat of reaction or enthalpy change of reaction is equal to the enthalpy change of reaction in equation 1 plus the delta change of reaction in equation 2. Okay. Summation, because this is Hess law. The definition of Hess law is the constant heat of summation. The enthalpy change of the reaction, okay, is equal to the changes of the heat involved in the equation. So it involves in equation 1 and equation 2. So you never subtract this, okay? You get always addition. Okay. So delta H1 now, it will become now negative 286 kilojoules mga palangga plus delta H2 plus negative 247.5 kilojoules. Why I will put always plus sign here before putting negative? Because the students will interpret that I subtract directly. You get the point? Since the rule is to plus, because this is addition, summation. So if I don't put negative, anyway I can put directly. For the purpose of better understanding, you need to put positive. Means this part is additional. Addition, not minus. So it will be confused for the students. Like that's it. Because it will just feel this in something like this. 288, 6 kilojoules minus 247.5 kilojoules. So they will interpret that this is minus this delta HRXN. But they don't know that that is only through the sign. It will become minus there. It's not the process. It's not the whole process. Something like that. So the answer is negative 286 kilojoules minus 247.5 kilojoules is become negative. Add two negatives. Add two negatives. Your answer also are negatives, right? You get the point? Okay, nga palangga. So it's gonna be 247.5 plus 286 is equals to 583.5. We have negative 583.5 kilojoules. The enthalpy change of reaction and the heat of the overall chemical reaction. Okay, so this is your answer now. Negative meaning to say the heat is being released to the surrounding coming from the system. Okay, and then this is an exothermic reaction. Exothermic. Okay, and then exothermic, this is spontaneous reaction. Okay, because it has a negative sign. Spontaneous, and then this is a reversible chemical reaction. Okay. Look at the overall chemical reaction. H2 plus O is equals to H2O. It's very impossible for H2O to decompose into H2 and oxygen only. Okay? As a monoatomic oxygen. H2O will always decompose into hydrogen gas plus oxygen gas, but never oxygen only. The difference between oxygen and oxygen gas is the subscript. Because oxygen gas has 2 on the subscript, all mentioning the word gas, especially the inert and noble gases in the last group in the periodic table. For example, here, the inert or the noble gases, neon, krypton, xenon, argon, like that. Okay, if you try to put a gas, these 2 always put, just like chlorine, fluorine, bromine, like that. These are halide group, halide or halogen group. When you put that as a gas, it's a chlorine gas, bromine gas, it will become Br2, I2, Cl2. So the word gas there would represent the subscript. But if you will not never say gas, it's still chlorine, fluorine, bromine. So you need to know the technique, something like that, okay? In putting your chemical reactions, you need to know the technique, when to put that way, when to eliminate that way, like that. For example, I will say hydrogen gas plus oxygen. And then you will say your product is water. No, it can never be, because I'm only talking to you oxygen, not oxygen gas. There's a difference. You get the point? We need to be particular. This is chemistry grammar. You know the point? If we have English grammar, we have also chemistry and physics grammar or science grammar, something like that. And then your purpose really is to produce one molecule of water or two molecules of water, but you add oxygen to hydrogen gas, it can never be. Okay? You will just add both gases to produce water. So hydrogen gas plus oxygen gas, not oxygen. Get the point? And then if we need to balance only by means of a chemical bonding, then we need to put two. It depends on the situation, where is the topic you are referring to. Chemical bonding doesn't involve the subscript also. You know the point? Mga palangga, ganon. Okay? It's gonna be like that. Okay, so you can never also say H plus oxygen gas. Okay, H plus oxygen gas like this. It's always be H2 plus O2 like that to yield also molecule of water. Okay, so if you really insist it's like this to be like this, then do the redox. Okay, H plus oxygen negative, ganon, negative 2. So that's redox or ionic bonding, right? But it's not really bonding the topic for chemical reactions. Okay? Ganon. Okay. Then if you try to check that out, guys, these all equations are balanced from 1, 2, and 3. Okay? If not balanced, then your delta H of reaction or enthalpy change of reaction is wrong. Okay? Because you matter with the manipulation of multiplying that with number of moles. So if the number of moles are not perfectly balanced, then it will be in error. Okay? In equation so far for this Hess law constant heat of summation. Because my last vlog for this Saturday night will be on another version of enthalpy change of reaction that involves standard heat of formation. Okay? But, but before ending this third vlog, I need to show some information for you guys to memorize completely. Okay, so that you have, stacks or stock knowledge, something like that. So let's say Q's meaning heat, right? So we can maximize the different formulas of heat, a combination of general chemistry lecture, physics, thermodynamics, physical chemistry, and unit operations point of view. Let's rumble all the heat energies formulas. Okay? So while you are still in the first year college, adopt the culture and habit to maximize all the formulas. Okay, go to the most basic and easy to manipulate and easy to memorize and easy to manage, and then correlate that somewhere along the way, so that day by day you can memorize that also as you progress your year, second year, third year, fourth year, fifth year, and then it will retain to your hippocampus, the storage of information part of your brain. Okay, in your cerebral part of your brain, like the retention of memory, information, and knowledge found in the hippocampus. Charot. And then your neurons will easily absorb that because it really regulates impulses, electrical signal, the positive and minus signals. We have current in our brain cells, mga palangga. We have polarity in our brain cells. Okay, that's why the neurons will activate in order for us to think, to speak, to write, to move, to eat, to dance, to sing, to fight with other people, okay, to pray, to sleep, to rest, or whatever things we'll be able to do in our daily lives. It's in the process of our neurons, okay, because the central nervous system responsibility, okay, in order for us to behave normally in the community and in the society, okay, like that. So Q's first formula of Q, which is a very basic one, gas version, we have the Q is equals to mc v dt. So most of the times in thermodynamics we will use this one. Okay, now let's do a little bit varying so that we will not be dependent in this gas formula of heat. We need to modify a little bit. Mass times specific heat capacity times the delta change in temperature. Put triangle, meaning change in temperature, the delta, something like that. So temperature changes from higher temperature to lower temperature, or we say final temperature against the initial temperature. So Tf minus Ti, T2 minus Ti, Tb minus Ta, or mention the particular substance you are referring to, which is the first substance, second substance. For example, if you are mixing the water and the metal, then put Tm, like that, Tw for water, for the representation of your temperatures, like that. Then for water, you will say TWF minus TWI. You will carry the W, something like that, to interfere with the other substance, which is the metal. And the metal also you say TMF minus TMI, or TM2 minus TM1. So you should be particular on the subscript identification labeling, so that you will not be confused during your computation and calculation regarding this topic, which is related to thermochemistry, thermochemical equations, and also the Hess law, the constant heat of summation. Okay? Like that. Okay, now this is equation number 1. Equation number 2, Q pa rin. So this is not familiar. Take note mga palangga. This is not familiar, but this is very logical to be used all the time. And we take for granted for this. So this is Q is equal to the heat capacity times the change in temperature. Notice what I mentioned, heat capacity. Heat capacity is not the same as specific heat capacity. So, if you're teaching chemistry right now, I would advise for the professors and instructors to differentiate the difference of the technicalities of the terms, so that the students can understand really what it's all about. Because they will be confused because they are not yet finishing their course in the entire 5 years or 4 years engineering course. They're still in the preparatory part. So if you feed them with substantial information, then that will be their weapon in going to second year college, third year college, fourth year college, as a reward or a bonus to them. Something like that, okay? You get the point. So we should not be selfish or too much egoistic, always trying to be, to praise ourselves, that we are good than them, our students, like that. It should not be like that. We should have a symbiosis relationship in biology. Remember the topic? Give and take relationship is a symbiosis relationship in biology. Okay, if you remember that one. So there must be give and take to sustain the relationship among the two, just like girlfriend, boyfriend, husband and wife, children to their mother, children to their father. You should have good relationship by having symbiosis relationship, give and take. For example, if I am a child, then I have to study hard as my reward for my parents to have good grades, because your parents are giving you money to pay your tuition fee, to give you food every time you're going to school. It's just like that give and take relationship. Okay? It doesn't have to be money all the time. So it's always also how you behave properly in the school, how you achieve good grades, like that, and your parents are very proud to you, something like that. The same also with the parents, okay? If their child is working very well and then excel in academic subjects and always be in the top 5, something like, you will also reward them. Something like that as a paid off to what the children have been sacrificing for a year, like that. Okay, so it's gonna be like the guys give and take relationship. Okay, so if you have also another example for like an employer and an employees, the employer also will give and take because the employees are giving services to the employer, the employer also will give reward to the employees, something like that too. So that we could have a sustainable business industry, something like that, or sustainable company, factory, or whatever organization that we're trying to work with, something like that. So symbiosis relationship, the context in biology is very important in our day-to-day life. Okay, going back to the topic. So number 2, Q is equals to C delta T. So C is heat capacity mga palangga. Tabihan kay kuno, so heat capacity. So, atong tanawon mga palangga. Okay, hindi ko katugod eh. Wait, katugod nila guys. Uy, grabe. Okay? So, heat capacity. Heat capacity mga palangga is delta H. Okay, delta H over temperature. Okay, so meaning to say calorie per Celsius. Okay, joules per Celsius, kilocalorie per Celsius, kilojoules per Celsius. Okay, or you can vary that as long as you have the unit of energy at the numerator and the unit of temperature is in the denominator. So whatever units of energy you like, then bingo. That would be your heat capacity. Since the adjective describing the capacity is heat, English, heat capacity. It is a description to describe the capacity. What kind of capacity is that? Because there's a lot of physical properties and physical quantities. But at this point in time, I'm using heat capacity. So that means heat capacity. Okay? Like that. Heat. So be sure that your numerator unit will also be heat energy because it is mentioned specifically here that it is heat. Not electrical, not mechanical, not radiation, not pneumatic, not hydraulic, not kinetic, not potential, not mechanical, and chuba chuba chuchu and the other energies that we have in our planet Earth. Okay, something like that. So, this is taken for granted, huh? Equation number 2. Don't be complacent. Complacent meaning, in English, meaning you are taking for granted and you're trying to be lazy that you will never memorize that, you'll never learn that because, oh, that's very easy. I don't have to, like this, I don't have to know that out, like that. So that's complacent. So in Bisaya, kumpiyansa. Or kumensa na kayo. So don't be complacent because sometimes it will also comes out in the examination. What will happen here? The problem will say only, if the heat capacity of water is like this, blah, 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 at standard temperature, what is the heat energy absorbed by the, let's say, absorbed by the wood? Diba? Wood is your substance. Okay, the wood, ganda diba? If the wood is immersed in a container of water, like that, and the temperature is 25 degrees Celsius, like that, and the heat capacity is like this. Calculate for the heat. But take note, we are only doing given only the heat capacity. It's not the specific heat. Then we will use this one. No, it's not. Because this specific heat have grams in the denominator. Mabuang ka. Because the wood has not mentioned the mass. No problem. You get the point? My problem doesn't mention the mass. Then do not use the specific heat capacity because the specific heat capacity have grams in the denominator. So it will be useless at all if you try to plug in, if you try to incorporate, or if you try to substitute that in your equation. So better use the equation number 2 that tells only heat capacity times the change in temperature. You get the point? Any questions so far for question number 2? And let's go now to equation number 3. Okay, equation number 3. This regards to molar enthalpy. Nakakaloka, right? So Q. Okay, instead of using mass, use the number of moles letter N times the molar heat capacity. Okay, so molar heat capacity times the change in temperature. Okay, what's the difference between molar specific heat capacity, and specific heat capacity? Okay, I'll try to discuss it to you guys because this is the thing that I did not know very well when I was in college. Okay, I was already a licensed chemical engineer when I know this stuff during my research, during my day offs, like that, and I go back to the Philippines in a vacation. I really love to read, to scan books, like that, information. I don't into movies. Really, I don't really that watch movies. I go to academic information. Really, and some talent search, singing, like that, entertainment shows, and politics sometimes. I am not into movies, really. Okay, except for, sikat na kaya popular Hollywood movies that is very, grabe na dyan kayo, matanaw ko, but ordinarily, I don't prefer to watch movies. I go really to academic information, science, chemistry, or a little bit of politics. Sometimes I also watch sports, okay, like that. And then, mga ganun, Olympics, Asian Games, like that, gymnastics. Most of the times, talent search and singing. I've watched on YouTube, like that. Singers, I research singers also, their achievements, like that, okay. And then, that's all, okay. My whole time will be spending with that. You get the point? Okay, like that. So, it's gonna be molar heat capacity for equation number 3. What is molar heat capacity? Okay. Molar heat capacity, CSM. Okay. So, Sotero, why CSM? Okay. C is the specific heat, and S stands for S, the specific heat. You'll just add the capacity. And then M is molar, the first letter of molar. That's why CSM. So, in short, this is an acronym put in a subscript approach representation. Subscript. Okay, because this is in the subscript, right? In the top, that is superscript. But this is subscript in the bottom part. Okay, something like that. Okay, now, the CSM, or the molar heat capacity, or specific heat capacity, is equal to joules per mole temperature degree Celsius. Okay? The CS here in the equation number 1 is specific heat capacity is joules gram degree Celsius. Take the difference. Okay, in specific capacity we use grams in the denominator. Okay, in the molar specific capacity we use mole in the denominator. The common is the numerator and the temperature beside the gram and mole. Now, if we try to express also the heat capacity, which is only C, there's no subscript, only C, right? So it is joules per gram, or per Celsius. There's no gram and there's no mole. So take the difference and then try to evaluate properly and substitute that in this equation 1, equation 2, equation 3, which is more appropriate. Okay, because you can cancel that out somewhere along the way. And then the simplified answer, oh, bingo, this is the correct answer. As long as you can derive Q, which is cal, J, BTU, like that, without denominator alone. Without denominator na siya, the Q. Okay? So that's why you can see problems, guys. If you try to look several problems in engineering, particularly to thermodynamics, physical chemistry, or general chemistry, the heat really don't involve most at the denominator unless it is an enthalpy change of the reaction, delta H of the formation of the reaction, heat of reaction of the reactant, heat of reaction of the product, or heat of formation of the reactant, heat of formation of the product, the delta H chu. Okay? There will be a lot of versions of capital H, but not Q. Okay? So, ang mga delta H na siya mga sulod-sulod sa ubos sa denominator. But ang Q, exclusive sa energy lang yun siya. Calorie, joule, like that. That's why when the problem asks, calculate the heat energy range, like that, or like that, blah, 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 so and so, then you need to cancel the denominator. Okay? Like that. And the denominator will play around in your stoichiometric relationship because there's a lot of moles there in your chemical reaction. And then you can cancel that out if that is molar heat capacity. Now, if it is in terms of grams, then you convert that going to mole or going back to grams. It depends on the situation. As long as it will be cancelled, your denominator, and what will be left is the heat Q alone, which is a calorie, kilojoules, joules, whatever unit you want, or British thermal unit, if you like also, right? So if I speak, for example, if I give you BTU per pound, what is that? So that is already delta H. Because there's a pound at the denominator. So we will call that as specific enthalpy. Okay. So we should not also, we should be articulate and specific to the terminology in science. I will say specific heat. So there must be gram in the denominator. That's why I told you, right? Specific is a gram in the denominator. But that is not limited only to specific heat. It could be applied to entropy. It could be applied to density. It could be applied to whatever, internal energy, like that. Because sometimes they will put in this way, calorie per mole. So that is enthalpy or molar enthalpy. Because the denominator is mole. If grams, it is a specific enthalpy. And then we have also the enthalpy regular. The enthalpy regular, just like coffee, not 3 in 1, there's no denominator, just like the heat. Calorie, joules, like that, blah, 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 so on. So you should be particular of the word molar, specific, like this. For example, I will say, calculate the molar density of water. Your answer is not grams per ml. It should be having mole, okay, in the denominator, because I said molar density. You get the point? So if I will say, calculate the molar mass, of course, there's a mole in the denominator, which is the molecular weight, grams per mole. That's like molar mass. Okay. If I will say, calculate the molar volume, what do you do for that? So meaning to say, there's a mole in the denominator. It should be kilogram per mole, gram per mole, pound per mole. Because molar volume. Now, if you compute that as a volume regular, you will be wrong in your answer during examination. You have still to multiply that in a certain amount of mole in your chemical reaction, or the gram is given there and converted to mole so that you can multiply that in terms of calorie per mole, blah, 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 cancels and calorie left. Like the things like this, you should be alert. Okay? First year college students, specifically the, chemical engineering, these chemistry students only. Yeah, because we have more on science and chemistry. Not too much with other engineering courses, but they have also chemistry, right? But that is not their, masterpiece, something like that. Okay, or expertise, like that. And now we go to the equation number 3. Number 4 na ito mga talaga, no? Okay. Another version of the formula of Q is this. Q is equals to normality, N, small letter N. Then delta H, chuba-chuchu. So what's chuba-chuchu? Chuba-chuchu means anything. Okay? So what? Q is equals to N times delta H. N is the number of moles. This delta H is the heat of vaporization, heat of condensation, heat of sublimation, heat of fusion, heat of deposition, heat of vaporization, like that. I just put delta H because general in effect. If I will put vaporization, I will also put subscript V, delta HV. If I say fusion, I also put F. Okay? Now, since the partner is N, your denominator is always mole. You get the point? So this will be calorie per mole, kilojoules per mole, because the partner is mole, so that we can cancel that one. What will be left is the Q, which is calorie, kilojoules, the same as equation 1, equation 2, equation 3. Right. Now this is equation number 4. Equation number 5 for heat. Q is equals to M delta H. The same story with the delta H chuba-chucho. Okay, different. So this delta H chuba-chucho refers to the phase changes. PHASE. From solid to liquid, liquid to gas, gas to liquid, like that. Okay, like that. So this mass already. Okay, in the equation number 5. So mass times the delta H. So expected that your denominator is gram. So it is, the unit of delta H will be calorie per gram, kilojoules per gram, so that we can cancel that here. Now, if you are confused, it's easy to manipulate these two. Okay? Like that. I'm introducing only the direct formula. Because, for example, you forgot this Q is equals to N times delta H. Since you have grams given in your problem, then using the molar mass, you can get the number of moles. Okay? Or using the stoichiometric relationship in a balanced chemical reaction, you get the number of moles starting from the grams. Gram to mole calculation is the name for that in stoichiometry and chemical calculations. Something. Or you can get also sometimes the number of moles in your PV in RT equation. Especially if there's a lot of quantities given, the volume, the gas constant, and you can feel that, it is an ideal gas equation, I have to use this one. Or the chemical reaction. Okay, like that. But the most perfect to be used, guys, I tell you frankly, stoichiometric chemical reaction. It's only secondary for the PV in RT unless it is only a phase change. For example, solid ice, okay, 2 grams of solid ice need a heat of blah 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 kilojoules blah 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 to make it a liquid. Like that. Calculate the heat of reaction. So you don't have to do the stoichiometry because that's only phase change. Okay? Another one, H2O solid equals to H2O liquid. So this is evaporation or vaporization. So use this. Either this one or this one. Since my problem don't mention the mass, only the moles, because 1 mole of H2O solid is equals to 1 mole of H2O liquid. Even though I will not say verbally the mole, it can be reflected in the phase change mole. So that is 1 mole. So use the molar. Q is equals to N times delta H. So your delta H will be vaporization. Okay? And then your number of moles will be 1. 1 mole of ice converted to 1 mole of water, liquid. Okay? So that is melting process or fusion process. You get the point? Something like that. Okay? So if you try to force to use this mass, then convert by using the molar mass. Okay? Something like that. Okay. Now, if the density is given, use the density is equals to mass over volume. The technique in problem solving, the first or the priority is in the data. Okay? If it's in the problem. Secondary na lang na siya Secondary, you get that from the standards, from the tables, from the graphs, and the correlation to other topics. That's secondary only. If you have no choice, that's it. Okay, because you cannot solve the problem if you will never touch those standards, tables, and graphs, and everything, and the theoretical aspects for that. Okay, like that. So, data first. Sometimes, due to the insufficient data, you will try to do this graphs, tables, standards, and correlation of other formulas to derive another equation to back up what you are trying to solve. Okay? Like that. So that's equation number 5 for Q. Equation number 6 for Q. What else, mga palangga? Okay? So Q, we have, if you can still remember this equation, guys, nakalimot ko NRT ln P1 over P2 natural logarithm. Equation number 6. This is thermodynamic properties na talaga siya, guys. Okay? This one ha. Okay, so review the thermodynamic properties because that's what I remembered only. Q is equals to nRT ln P1 over P2. Okay, like that. You get the point? And the equation number 7 will be basing in your internal energy is equals to heat plus work in which heat is equals to the internal energy minus work. So Q is equals to internal energy minus the work. So there are 7 equations, okay, for heat to be used. Okay, and I did not include the other, another para-paraan. Okay, what I mean by para-paraan, you can establish by your own thinking during the actual, solution. Or if you try to make the questions. Okay, like that. Get the point. And then, i-include ko na ito dari arin ko guys. Sorry guys, I have to add more. 7 equations. Number 8, we add also the entropy based. Okay, so delta S entropy is equals to Q over T. Then you have also Q is equals to change in entropy times the temperature. This is also another equation of Q in terms of entropy. This one, 7 in terms of internal energy and work. Okay, equation number 9. Okay, so this based on delta H and okay, Q delta H, Q over M. Okay, Q over M, so it's already there, no need. So we need to insert the PV in RT. Okay, so how can I mag-derive kung ako akarong higayon na? So we can also compute heat by PV in RT. How can we do that? So let's derive. Okay, so that we can have maximum of 9 equations of heat. Okay, like that. So how can we do that mga panangga? So let's say I have the Clausius-Clapeyron equation. You still remember that one, guys? Naabot mo ko sa Clausius-Clapeyron. Nakakaloka. Diba? Thermodynamics. Nakakaloka yung thermo. My gosh. Okay. Now I have here like this Clausius-Clapeyron equation. Natural logarithm pressure 1 over pressure 2 is equals to heat of vaporization over the universal gas constant times 1 over T2 minus 1 over T1. Aba, nakakaloka. So how can you insert that heat there? I can insert because there's a delta HV here in 4 and 5. Okay? Delta HC. So I will manipulate here. So delta H is equals to Q over N. Then substitute that there in your Clausius-Clapeyron equation. Oh my gosh, on the spot. Ln P1, P2 is equals to, substitute delta H which is Q over N. Like this, Q over N over R. 1 over T2 minus 1 over T1. And play around the, the math for this. How can you do the math for this? If you have like this, Q over N over R, then if you try to reverse that one, like this, diba? So, like that. So 1 over 1 will become Q over N times 1 over R. It will become Q and R. Okay? Q and R na siya. Akong i-change ang Q and R. Okay? So Q and R. Oh, ano siya in terms of heat, but we need to solve for the heat, mga palangga. So that we have equation number 9. Okay, so how can we do that? Okay, Q, okay, crisscross multiplication. Tararat, ganon. So, Q1, P1, wait, Q1, P1, right? Like that. And then this is going to be equal to Ln, P1, okay? And then, like this, NR, TC, this over, okay, like that, if you like this, so this is NR, TC, minus T1, like that. So Q will be equal to Ln, P1, NR, T2 minus T1, over, this is P2, right? P2, ganon. So you will say Q is equals to Ln P1, P2 again. Okay. And then NR. Okay, so you will also transpose the temperature to make it more simpler. T2 minus T1 times the whole thing NR. Okay, you have now the equation of Q in terms of Clausius-Clapeyron equation, which is the natural logarithm of pressure 1 over pressure 2 times temperature 2 minus temperature 1. Bracketed all, times the number of mole times the universal gas constant. But it looks like very complicated. Who dares to use this equation number 10? It can be used if there's pressure involved. Of course, if there's no pressure, then don't use this. Okay, things like that. And there's also universal gas constant needed. Okay, so there are at least 10 equations to solve heat content or heat energy. It's up to you. Okay, for the PV and RT, no need to get back to you for the PV and RT. We can also, question number 11, heat energy number 11, question, equation of heat energy number 11 from PV and RT. How can we derive? Okay, let's derive. Okay. So this is it, guys. I love in the spot. Okay, this is PV in RT. Okay, since we are looking for the Q, okay, how can we do that? In this in RT side, there's no Q relationship there. Okay. Okay, you can have also by having the delta HB. So let's say delta H, Q, N, and so for the N is equal to N, Q delta H. It's also possible. First option. Second option, work for the PV thing. PV in thermodynamics is just equal to work. That's why, guys, we come up with this equation because this general gas equation, ideal gas equation, PV and RT, is coming from thermodynamic equation. It's gonna be in the second law of thermodynamics. It states that work is equal to the pressure times the change in volume. That's why the W will be rejected and automatically it will be there, P times V. So actually this is also equal to work equals to nRT in a thermodynamic approach. You get the point? This is just the same. This W taken from the thermodynamics, this PV. So mahibong magulo sa dyan, they will be surprised, why hindi kalita ang PV? Okay, so if I am the instructor, I will explain where this PV coming all about. Now I need to discuss, guys, this pressure times volume is coming from the work. In the second law of thermodynamics. Ganon. Di ba ang saya-saya pag ganon talaga ang instructor? Okay, nakakatuwa. Okay, ganon. So, sa to say, mukalitan yun ng question. PV and RT, you don't know where this PV comes from. Because this is not already a basic formula. This involves 1, 2, 3, 4, 5. This involves 5 basic quantities or variables. So, this is not already easy or basic equation. The basic equation is density, because it involves 3 quantities only. Density is equal to mass over volume. No need to say, where the density coming from? Right? It's obviously funny to ask where does mass comes from. Because that is directly measured. That's measurable and quantifiable. I don't need to ask where that comes from. If I will measure the volume of the water, do I have to ask what theory is that? If I have already the device, then I can measure the volume. If I have the graduated cylinder like that. But in this case, it's different from the PV and RT. It's not like that. That is not measurable. This is intrinsic property. Okay, let's review one by one. Pressure is intrinsic property. Intrinsic property meaning not measurable. Okay, not dependent on the size of the system or the amount of matter present. Okay, then moles. Moles is measurable and volume is measurable, but the three are not measurable. The universal gas constant and the temperature are all intrinsic property. So meaning to say mixture of measurable and non-measurable. Now how can you easily say, how can we get this all blah blah blah? So go to the derivation. Okay, now we have work is equal to nRT. Now, okay, now since I have delta E is equals to Q plus W. Solve for W to substitute that here also. So W is equals to, wait for a while, okay. Wait, it transpose mo siya. So, internal energy minus, you need to compute for the work because work here is your equation for equation 11, right? So, work is equals to the change in internal energy minus the Q. Put that here. So, change in internal energy minus Q is equals to nRT. So this is your new derived equation. Okay? But you are after for the Q. So we can say also Q is equals to nRT minus the change in internal energy. So this is negative, cancel, cancel. divide both by negative. So this is delta A E minus nRT. So we have new equation for the Q in terms of the PV and RT thing, which is heat is equal to the change of internal energy minus the number of moles times universal gas constant and temperature. So this is our 11 equation for the heat energy. 11. We derive another. And now, we still derive another. Here, the option 1. Okay? Which states that N is equals to, Q delta H, right? Or Q is equals to delta H times N. Substitute the N in the PV and RT. Let's go back. So PV is equals to Q, chararat, Q delta H times the R times the temperature, right? PV is equals to crisscross multiplication in algebra, math. Crisscross multiplication. So PV delta H Q RT. Solve for the value of Q. So, if you solve that, divide by RT. Oh, so that makancel mo ang RT. Okay? So, it will become now, Q is equal to pressure times volume to the change of enthalpy of the reaction. Okay, mga palangga. And then, universal gas constant times T. Wow, nakakaloka. So, equation number 12. So we have at least 12 equations of heat energy, including the thermodynamic approach, which is the PV in RT. Add 2, which Q is equal to delta E minus in RT, and Q is equal to P times V times delta H RT. So these are new derived equations of Q. Okay? Like that. So these are the things I missed most of the times when I was in college because it was not really discussed in this way. Okay, like that. Imagine we know already we know one only equation of heat for the majority, right? If you are an engineer, I know that. Me also, if I don't research that much, I think I have only 2 or 3 equations of heat. But due to my research, okay, I found out 12 equations of heat energy. Imagine 12 equations of heat energy, and you can play around which is more appropriate to solve the problem based on the data given in the questions you will be facing in the future. Okay? Ganon. Okay guys, any questions so far? Mga palangga. But take note, this is another also one thing, not really a formula or equation, theory. Okay, at constant temperature and pressure, your heat content will be automatically equal to the delta change of the enthalpy, delta H. This one. Q will be equal to delta H at constant temperature and pressure, automatically without question. That's why some problems will ask for the delta H, and it's awkward for the students to do that. Because in the classroom instruction, our instructors, professors, and teachers will always put Q as what we are trying to find out. But if you face examination, it will ask what is the enthalpy change of a reaction. And then they give in the mass, the change of temperature, specific capacity, and you have no idea. It's just the same by heat. So you will use delta H is equals to mCp dt. Okay, not all the time Q is equal to mCp dt. It's also delta H is equals to mCp dt at constant temperature and pressure. You get the point? So not all the time. One am I wrong? Okay, lacks of theory and concept. You get the point? Okay, basically that's the major thing. If you lack the basic concept and basic foundation, you will almost fail. Okay, something like that. Okay, so work for the basic foundation. Ganon. Strong foundation. Okay, to increase the stability of the structures of the building or any infrastructures. So, if knowledge, so that it will stabilize your knowledge, like that, or increase your knowledge, something like that. Okay? Ganon. So, basically, math and science ang akong puntos niya ng higayon na. Okay, thank you so much, everybody. Any questions so far, mga talangga? If you have questions, then you can raise that in my social media accounts, Facebook Messenger, like that, Twitter accounts, like that. I don't have that talk, okay? And then, like that. I'm not active in Instagram, sorry. And I'm not also active in the LinkedIn, okay? I'm active in Facebook and YouTube. only because I have YT channels and have two Facebook accounts. So you can send me message there if you ask help regarding science, okay, particularly chemistry or a little bit of physics or whatever. Maybe I can help you a little bit like that, okay? Get the point? Because that is our line of, expertise and masterpiece, something like that. Okay, then if I cannot answer, sorry for that. That's all I can give to you guys. Because we have limitations also. Okay, you get the point? Okay. You can subscribe to my channel if you want. And then you can also click the notification bell for some news updates that I am a singer, eternal voice. Bye-bye. God bless everybody. See you later. See you tomorrow for my another vlogs. Bye-bye. Have a nice sleep. Sleep na ba? Okay. Nakakaloka. Okay guys. Bye-bye. Ay, sumakit yung ulo ko. Nag-drive si Junjun. Di ba? Kaloka.